Welcome back to VTU's e-Shikshana program on computer-aided engineering drawing. Particularly, I am working on module 4, that is isometric projection of solids, say prisms, pyramids, cone, cylinder, etc. So far, we have discussed the basics of isometric projection. What is isometric projection? How exactly you draw isometric projection of basic figures like square, rectangle and the circular item. And also we have discussed how to draw prisms, pyramids, frustum and the blocks of square and rectangle items. Now let me take the cone and cylinder and also frustum of cone and the circular block one by one and discuss. Now here I have cylinder and cone and frustum of cone and circular block, okay, of specific dimension. The dimensions may vary as per the requirement. Here I have taken 70 mm height, 50 mm base dia. Here assume that it is 50 mm dia, base dia and height is 70. Here also you can take around 60 mm height and also the outside circular concentric circles which represent the top view of the actually the frustum of cone, this one, and here this is 30 or 20 whatever and the base item is 50 mm. Now the actually the height is referred to as thickness here, it is around 15 mm, 20 mm whatever and also 50 mm dia. Now how to draw this? This is as good as drawing isometric projection of square shaped solids. It may be the prism or pyramid and also frustum of pyramid and also block. Same you have to do 50% of the time you have to work same. Then there is small deviation to get the curved surface. Now let me start with basically let me review how exactly you draw the isometric projection of a circular lamina or circular surface. Now whenever you get circular surface other than rectangle and square, you have to enclose it in a box. Okay, so assume that I enclose this in a box. I will get square. Okay, you have to draw isometric projection of a square. You know how to draw isometric projection of a square. Okay, so you have to keep either side 30 degree and take 50 mm isometric draw if you are very particular about isometric. Now onwards let us say it's isometric view only for easy understanding and also easy processing of teaching. See, I take 50-50 and also this one. Now to get the ellipse, isometric projection of a circular lamina is ellipse, isometric projection of square is rhombus, isometric projection of a rectangular lamina is rhombus, parallelogram. Now to get isometric projection of the circular surface, I have to draw 50 mm, 50 mm either side and also draw parallels, or if you are doing manually, keep plus mark and then take the half of the side, either side you mark from this center, then take total draw arc. This we have discussed in the last session. Same thing let us do here. And how to keep it, how to complete the circular lamina, that is ellipse, I will tell you here. Mark midpoints of the sides, mark midpoints of the sides, then select obtuse angle corners. It may name this as 1 and 2. I have to identify centers, then join them. See, all these lines which are joined with the obtuse angle corners with the midpoints of the opposite side all are equal. Okay, and also let me keep this as MN and PQ. This is only repetition of what I have explained earlier, just for your understanding. Now take 1 and 2 as centers, total radius, draw arcs. Then take 3 and 4 as centers, the intersection of these lines gets you 3 and 4. Then 3M equal to 3P, 4N equal to 4Q equal to radius, draw arcs. We call this bigger radius as capital R and smaller one as small r. So this is how you get the ellipse. This is only rough work I am working. Now let us start from this. Draw 2 plus mark with a particular axis reference. This is what I am doing for manual working. I will tell you how exactly I work in computer. So you keep this half of this 50, 25, 25, draw 2 arcs with compass with this as center. Then take total, don't lift the compass, draw arcs. Then draw. That's all you have to do. Then mark midpoints, join them, and then take obtuse angle corners as centers, draw arcs. Then this two as centers. Don't take the center. Center is most dangerous point here. Take only these 2 points identified. Then draw arcs. You'll get ellipse. In computer, what you have to do is do all these things, then draw this, then check with ellipse by 3 points, okay, or 2 points, whatever. Next, same thing you have to do here manually. In computer, you take this, move and fix it, okay, with this as center reference. This is OB, and this one is OT. You create one and then move this, then fix it here. That's all. Here, I have to repeat same thing. Draw arcs, manual working, then whatever the procedure I have told, take 2 radius, take total, mark, and then fix midpoints. Already I have fixed, you draw vertical line and get it if you have proper instrument, otherwise you mark points. Same distance you draw here, that's all. Whatever you have taken, take this as center, draw arcs. Then same procedure. Okay, now draw this. You will get ellipse. Now, how to complete this? Draw tangents, vertical line only. No other line will match you this. So you must draw vertical lines and then complete. So this is how you draw. This is the outline of the figure. All are right lines now. Now how to dark? Top face is visible as usual. Top face is visible. Dark it. Draw smooth curve, use French curves, whatever available. Then boundary lines completely dark. Up to this, tangent point is this only, diameter point. Then draw dark line. Okay. Now this is what you can do for the cylinder. Okay, so this is how you complete the cylinder. What about the other portion, curved portion? Let it be light only. So this particular portion is to be made light. All other lines are construction lines, let it be there. All must be very light. This is how you create it. Then one more thing is left, that is axis representation. That is very important, from base center to top center. Identify with the convention. So this is the procedure to complete the cylinder. Now what about the cone? Cone is actually very easy. Create the base as in the cylinder and then identify the center and then take out. So this is how you create. It's the same thing, follow. Draw. First create this rhombus by arc method, whatever I told. Otherwise you can take 30-degree line and draw parallels, whatever. So better is manual. Yes. Computer you have to do like that only. Then identify midpoints. Create this. Base surface is over. Then identify the generator. Very carefully draw this generator, outer generator, extreme two generators, by keeping tangent to this ellipse at particular point. You can do it. Suppose that I have a curved surface, I have a point. From this point I have to draw a line tangent to this. Yes, I can draw easily. Wherever it touches, you mark it. In computer it's easy. Take the line, have start from this and touch this curve. Automatically it will give this symbol, tangent line. Then you stop. That's how you create. Now, how to complete this? Dark boundary base is not visible. Since say I have the dark color base, I will keep it on it. Look from this direction, any direction, base you cannot see. So base is not visible. Boundary is visible now. So boundary is visible. Yeah. Now you see that you should not join these 2 points. You should keep these tangent points. Suppose that if I keep any starting point, that should show end point above this, end point above this, end point of this line above that. Then complete this curve, smooth curve, using French curve or whatever, manually. In computer, automatically it will be created. And then suppose if you select this in computer, the entire thing will be selected. For that you have to split. Use split command and then split at this point and split at this point. Definitely you will be darkening this and also from this portion, more than half of the portion you are being darkening. This is how you complete. Then as usual, you are supposed to identify axis, because no edge, no corner here. It is only curved surface O, B, base center and top. This is vertex V. So always identify with V. Next comes frustum of cone. Frustum of cone. So we have already discussed this with the solids and also other development. Okay. So base center, top center. In case of frustum of a square, this one. You have to draw this first. Only thing is, you need not have to draw the slant edges, that's all. You have to develop the base of the square, develop the base of the top face of the square, and then include that with as ellipse. That is, you are going to have procedure with this only. So now we are going to create frustum of square prism only, pyramid, square pyramid. Now same procedure you follow: base, plus mark, then use the arc method. Half of the side you take 20 if it is projection, otherwise view you take directly and take total mark. Then at given height, say this is OB. Now OT is the top face. Take plus mark again. OT to OB is the height of the frustum. Now you take, suppose that here I will give 30 as the diameter. This is 50. 50 it is over. 30 or 25, whatever given, you take half of it from the scale, isometric scale. If it is projection, if it is direct, you can take directly and mark. Then take total and mark this. Then same procedure you have to follow. You can do it very quickly. So very easy also. Instead of going for 30-degree lines, this is best method. Now take centers, same procedure you follow. Then create the top face by 4 centers method. Then since you know top face is visible, you dark it directly. I don't know. So ellipse you get. Okay. Then same procedure you follow here. Top face base. Okay. Now, what exactly is the boundary here? Boundary is very important. You have to draw tangent to these two conic sections by drawing a single line. So, tangent at this point, again tangent at this point. So, you are having these two. So, you can do like this. Just draw a line just touching both curves like that. So, that's what I have done here. In computer, it will take care. So, you have to touch this and then move tangent line, it will draw. It will show the symbol, you have to stop it. That will show. Now, draw this boundary. Again here, it is not exactly touching this diameter line or the major axis line. It is just above that, just above that. So, you have to take care. More the height, nearer the points to that point. Otherwise, if it is big circle and small, then you will have difference. Again, same thing, you have to create smooth curve using French curve or whatever. That's all about this. And then you need not have to draw dotted line, as I told you earlier. This is only the representation, and again axis representation is must for all the solids, OB to OT. Yes. That's all about the frustum of cone. So, base, top face and height. So, creating two ellipse at given height, that height equal to height of the frustum. That's all. Then last one is the block. This block is having a thickness of 15 and then diameter of 50, say. First you have to create the block. Unlike the square, I drawn only 3 lines or the outer lines, visible lines. Here I cannot do. I have to create 2 ellipses, one with the top face and other one base, and then join them. We will show you how exactly work that. Now you must be carefully do it because you should have patience, otherwise it will go wrong. Now keep this with very light line, then mark, draw lines, then 4 centimeters method, complete. Okay. Next, you can keep either OT or OB, no problem. Anyway, you have to create. This is the top center. Say this is top center. OT, OB, 15 mm. So it may be like this. So somewhere here you will get. Then draw one more line. I will use different colors so that you can understand better. I will use the black. I use blue now to create one more same figure with same diameter. Everything is same. Now draw this. You will get one more same figure. Mark, number of lines will be there. You must be very careful. Then draw ellipse. Yes. Now, how to complete? Draw 2 vertical tangents to do these 2 ellipses. Okay. You must get vertical tangent only. Now, which one to keep dark? Out the top one. Top one you keep dark. So, let me try the level best to make it dark with smooth curve. Okay, this is top face, ellipse. Then this tangent point. Yeah, this is tangent point. Till that point you draw vertical line. No question of this tangent above the major axis as in this. It is exactly same major axis points. Now draw smooth curve. Yes. What about the portion from this point to this point for the base? It's not visible, let it be as such. So this is how you create the isometric projection or view of cylindrical block. It's like a carom board striker. Okay, you can imagine that and then do it. Otherwise, any of this type, but this is like inclined. Okay, assume that it is straight. So this is very small block. Okay, if thickness is small, then it is called block. If it is height, sufficient height, then it is called cylinder, like prism and block. So this is how we create. You must be very careful in this overlapping type. You must have patience and complete. Only thing is, the tangent points at this. Okay, in case of solids also in top view we used to draw that. Okay, here also you must be very careful in doing it. Now let us do same thing in computer. We have to draw isometric projection or view of circular items, namely cylinder, cone, frustum of cone and cylindrical block. Before going to that, let me review what exactly the isometric projection of a circular figure, that is circular lamina, whatever we have covered so far. If you have a circular lamina, it's actually the cross section of the cylinder, base of the cone, or top and base of the frustum of cone, and also both top and base of the cylindrical blocks. You have to know better how to draw the isometric projection of a circular lamina. You know that unless it is square and rectangle, you can draw the 30-degree lines and do it. But here it's a circular lamina having curved surface, a curved line. You have to enclose that in a box and draw the square first. Then, after drawing isometric projection of square, view of square, then you have to work out the same with the 4 centers method. So, how to work out 4 centers method? You know, identify the midpoints of the sides and join them with the obtuse angle corners, 2 obtuse angle corners. Now, say M2, N2 equal to NP, NQ, all are equal. Let me call it as R. Then 3 and 4 are other 2 centers, 4 centers method. So 3 and 4 are the intersection of those 2 lines which you have drawn already. The 3 and 4 centers, the small r equal to radius draw, because small r is 3m, 3p, 4q, 4n. Then you get 2 sectors, you get here 1 and 2 as centers, capital R equal to radius, draw arc segments, 2 segments. Similarly, you have the 2, 3 and 4 as centers, draw 2 more arcs. You will get this. This is the procedure you have to follow meticulously. Then you get the figure ellipse, that is isometric projection of a circular lamina is ellipse actually. So you should work out this. So throughout this session, we will have number of times repetitions to work in 4 centers method. Now let us start working with the so-called the cylinder, prisms, etc. Now let us go for creation of the isometric projection of a square. So you also dealt with the how to create the square prism and square pyramid, and also a square and frustum of square and frustum of now we are working on frustum of cone, and also the block, square block. Now on the same lines you work with the circular block, cylindrical block. Now start working with this. Now this is, I have created the base center, base. Actually it is a square, you know how to create this 30-degree line and also draw parallels, you get this. 4 centers method, I will work here only for the benefit of you. Now how to create these points. So midpoints are already available, so you need not search for that because this IntelliSketch will take care of that. Now let me do this job. Yes, now start with this, join with midpoint. Again start with this, join with midpoints. Particularly the circular items you must be very carefully do it, otherwise it creates problem. Sometimes it will hang, system will hang. Okay, now take care of these 2 segments with the circle arc by center point method. So let me zoom it and do better. Okay, endpoint reference, endpoint reference. This is how we create 2 segments. Again 2 more centers. Take this as center, small radius, small r. Yes. Then again this one. Check twice whether it taken the centers properly. Okay. Zoom it and check it. So base of the cylinder is ready now. Okay. So unlike the manual method, in manual method you have to keep plus mark or the method you are following to do it. Now here it is not necessary. First identify the top center. See, this is the face center. Top center, say at a distance of 70 mm. Okay, height axis height is 70 mm. You know the axis type type 3 here 0.25 or 0.35 axis you identify. Keep it intact. Now at this center you have to repeat this. Now you not repeat, you just move and place it. That's all. So that's all the advantage of this computer aided engineering drawing software. Now you see that this is copy. You should keep there also and move the same and fix it there. Yes. Now we have identified the top face. Base is ready, top face is also available now. Now draw tangents. So try to zoom it and then do better. So draw tangent. Actually starts from this point only. That is the major axis, end of the major axis. Yes, midpoint of that curve. Yes. Now I have not changed this. Better you change the pattern of line. Before starting any activity, you start working with the required configuration and style. Yes. Point. Yes. Again, this midpoint and this midpoint of the curve. Otherwise, you will get tangent line. I will show that once it starts with the cone. Now, what are the lines to be darkened? So, because top surface is visible, boundary is visible, and this is also visible. Now, let us start working. Select the top face lines. Yes. And also the boundary. Okay. Now, dark this. Say for the proper viewing, I keep one little dark only I have taken. For explanation purpose only I am taking. You have to take 0.5. Next, I have to dark this portion. I can take, this is an independent entity, this big arc, but these two arcs are having the part above and one part below. I have to take part below this horizontal line, that is major axis line. What to do? Go for this split this arc at this point. Yes, split this arc at this point. Now you can see the requirement is only the portion below this you have to dark. I have made it. See, this only is selecting now. Now I have to select either side this segment and this segment and the total segment of this big arc. Now select these three. Earlier the total arcs are selecting. Now it's only the portion which you have selected are identified. Now you see this. This is 0.1 only I will select. Actually you are supposed to take 0.5. Now you see this dark, the top face boundary lines are dark. You leave this as such. So this is how you create the cylinder. It's very easy job once you follow the procedure 4 centers method. Now let me go for cone. So same procedure you have to follow. Create the base and then go up. Then I will tell you what to do. Now I am selecting this isometric projection of a square that you know how to create isometric projection of square now. Okay. Now 4 centers method. I would have taken the same thing. You can also do it. I will tell you how to do it. Right now, let me use this for the learning process. Okay. Now identify the midpoints of the opposite side for obtuse angle corners. That is the procedure. Again, one more obtuse angle corner. Yes. You join with midpoint. Yes. Keep this way. See that these two lines are intersecting at horizontal line only. That is where major axis of this ellipse will lie. So if there is any deviation, your procedure is wrong. Okay, check twice. Okay, now keep this zoom. Then draw ellipse. So center point, arc by center point, yes, again center 2, again arc by center point, then these two as center. Don't take this midpoint. This center point is most dangerous point. Sometimes people go wrong by taking that. I am repeating that because this is my experience. People keep repeating that unless, okay, this is center and one radius, draw arcs. Yes. Now go with height. So height, say for example, height you take 80 mm or 60 mm, whatever. More the height, then you have problem with the tangency. Better take the height equal to 60. Okay, better. Yeah, 60. Clarity will be there. Now let me take this axis reference. Let me fix axis 0.25 and style is third one, axis 60 mm height. Yes. After this, let me zoom it and explain. It's very clear. Yeah. Then start working for drawing this line. Now don't join this with the ends of the major axis. No, it's wrong. You have to draw tangent. See, you can see the symbol. The end of the line is touching the curve. At the same time, it is tangent. It is showing the symbol, circle with line, and also a line with crossed arrow. That means it is point on the curve. At the same time, it is tangent to the curve. So click there. Okay. Now I have not changed the style. Axis only is there. You can change it. So I will select and change the style. Thin line only, and also this line should be normal, that is thin. Yes. Now before going to that I will change, otherwise it will repeat. So you also get experience. The problem here, you always forget to do that. Always see that whenever you go for new activity, see the line for your requirement. See here also it is showing both the symbols. It's touching the curve, at the same time it is tangent. Stop there. Yes. Now after getting this overall cone isometric we got, then visibility. What are the visible lines? You have to go for visibility concept. Then this notice, see this the end of the line for the tangent from this point to this point it is visible, not off exactly. Unlike cylinder, you will get more than half of the ellipse base portion is visible, and remaining this base portion is not visible. So that is the characteristic feature of isometric projection. Now, so you have to split that. So how to split that, you know, take this, this, and at this point you split. Yes. See, this becomes a different entity now. Again, same way you have to do this. So again, go to split, and then select this curve and split at this point. Yes. Now only this will be selected. Only required portion will be selected. See, highlighting with color. Okay. Here also highlighting with the color. And this portion as usual we are going to dark. So now two end generators already fixed with the tangent lines, and also two portion either side below the tangent point, and also this segment, full segment. So dark those things. So this is not visible, boundary is dark, and then you know these three segments are dark. So this is so I am supposed to take 0.5, and purposefully I am taking 1 because of explanation purpose and also clarity of presentation. Now take this again. Yes, see, I have made it little dark so that you can see. This is how you create this. And one more thing left is axis is overlapping with the line, let it be there. Only if you want, you can even name this. Say this is base center O B OB. OB base center. This is V. This is the actual figure, 3D figure. Always keep capitals, small size. That's all. No small letter like projection. It's not projection actually. You can keep small size capitals. So this is how you create the isometric projection of a cone. Now we have to go for frustum of cone. So we have created the cylinder and cone. Now isometric projection of frustum of cone. That means you are going to have this as 50 and the top one as 30 or 25, whatever. So that you have to do. Now let me take up this. Say same thing. Reference is this only. What we have done, we have created the base and then created this also by scaling. We have completed this and then joined. Here we have to create the ellipse here and then go for scaling of that ellipse, reduce it to a required value and then place it. That's all. Okay. So now I kept this ready, hoping that you know how to create this. I could have taken the same thing, but problem with the circular items, it will hang. So here only I create, no problem. So here a force integration method. Yes. If you have the same type of figures, you can then copy and start working. You need not spend more time on creating this because already we have this base and then do it. Just for explanation purpose, I am doing this job. So this is say around 50. Now what I do is I will take here exactly half of this. Suppose that if this is 50, we have 30. 30 by 60, you can 50 you can do. Automatically it will change. Now what I do is I will first create the ellipse. So arc by center point. Then have this, some problem. Very careful. Yes. Now for this small radius, I got this. Now same thing I will reduce by size, say by 50%, and then place it there. That is top face. Okay. Now select this. Select this, then scale it. So I have to keep that same there and I have to work out here 50%, that is 0.5. Somewhere you keep, no problem. Now this one I have to keep at this position. That means top of the axis. So let me fix the axis. Fix the axis. Axis is say 60 mm. Line axis representation 0.25 T5. Axis representation base center select, and then top center you identify by fixing the height, say 60. Yes. Now I'll change the pattern, line pattern. Immediately after that you change the pattern, otherwise it will repeat. So normal, yes. Now in manual case you have to draw plus mark or create 30 line, etc. Here it is simply scaling it to the required size from the base and then placing it. Now you go for move. Take the center of this, and then you see that this is blank, and then keep that center with the top center of the ellipse. Okay, so that's all. Now the unnecessary construction lines for the top one you can remove. You can either select it and remove it, otherwise go for trim and trim this. Now the challenging part is the joining these two, okay, with tangent. So how to do it? Let us try. Line command, select this. See, you can see the circle, it is moving, okay, immediately, and change this. See, actually that circle is representing, it is actually the tangent there, and here also we got tangent. Yes, click there. Now see, it is not exactly the end of the major axis, it is just above. Here it is also just above. It is not end of this. If you simply join, then it is wrong. Here also the same thing. That is how you start working for drawing tangent. Then move up. Don't do this. It will catch center point. But you keep moving up. Then you have circle type. Then you move further. Then you have the tangent symbol there. Yes. Now it is very clear that the point, the either ends, the end generators representation in this figure are not joining ends of the major axis of ellipse at the top and major axis of the ends of the major axis at the bottom. It is different. Now it is tangent point. So how to complete? The top portion is visible, completely visible. So dark that, select. Yes. Then select the generators which you have identified already, and also there is one more segment, it is available, it is fully identified, dark lines. Then we will take up the rest. Yeah, I have made it thick because of explanation purpose. Now I have to create dark line from this point to this point. Okay, again same way whatever we did in the cone case, same. So select this, go for split, then select at this point, yes, then this becomes different entity. You just observe, if I touch this, the entire length is shown. Now once I split, the required, these two becomes different entities. So select this split, yes, then at that point you have to now select these two, either side, this portion and this portion, dark that. So this is how you can carry on with the required portion dark. So it is really interesting. You really enjoy this type of solids, particularly in isometric, whatever you have drawn. So you have created 3D drawings, and definitely it is very interesting. Now I have completed this. Dimensioning, what exactly the type of dimensioning? What you do is top this one, you can keep this side ready. So it's showing some 21, I think 20. So for some work I did here also, say 40, 20 you can say, and then dimensioning of the height. So that you can do, yeah. And here also it is, I have taken approximate, so it has come 21. Now it is 20, 40. You can dimension the top's diameter and base diameter. That's all. nothing else here. Now this is frustum of cone. Now to go for block, how to create block? Same procedure. Okay. Only thing is you must be carefully do it because of thickness is very small, like 15, 10. Like you have to create one ellipse here. So I could have taken this only and draw, but for the practice purpose I will draw again. See, midpoint, yes, join this midpoint, again take this midpoint. This is the advantage you have. Otherwise you would have taken measurement and do it. The IntelliSketch is giving all this. You should see that is on there. Okay, now create this. Every time I am starting from scratch so that you get understand clear idea about this. Should not commit mistake anyway. Yes. Now the problem with circular items means small deviation will change. See, you should take inside from inside. Yes. Okay. Now take from this. Again take this. Yes. Purposefully I have taken little big size here. Double the size of whatever the base given. Yes. Now this is let me name this is top center and base center. Okay. Now this point is okay, one capital letter O, sorry, O T, top center only. Let me take this as top center. Now I have to identify the base center. So at a distance of 15 mm, say. Let me draw a line, 0.31, okay. From this point, 15 mm, very small gap, yes, 15 mm, enter. Then fix and draw a big line, yeah, so that you can identify this dimensioning, and also once you move, this line should not move. So here I will say take this and move, okay, so that the top center is coinciding base center, that gets you one more. Now I will do, carefully observe, I take move with dark, yeah, because you have to retain that also. Yes, now this is the reference, this never changes, it stays there only, so that I can place it there. Suppose that if I draw small line, that also select and move, then I never get the reference. So see that is long line. Now you move this center, yes, click there. Now I got two ellipses, conic sections at a distance of 15 mm, okay, at a distance of 15 mm. Thickness is 15 mm. Yes. Now, what to dark? And before that, you have to draw tangents. So, tangents must be drawn from top ellipse to base. It's very easy. This is the ends of the major axis. That's all. Major axis. Unlike frustum of cone and cone, it's very easy job. Like cylinder, reference is there. Okay. Now the top face is visible, and these end generators in the isometric view are visible, and also from this portion, again you have to go for split this, again split this, make these two entities because it's single one. So let me do that now only. Split this particular curve at this point, yes, done. Now again come here, split this, again this curve at this point. Now I start working for the selection of segments which are to be darkened. Now these two opposite big curves, then this one, complete ellipse is visible, then this generator, end generators you can say in isometric view, and also this part of that curve, again this curve and this curve. So in one go we worked out, then we got this. Yes, see, this is how you got it. This is like a carom board striker. Okay, so you can think of that. You can imagine that type of or any powder box, okay, face powder box or whatever the package of this type or some article. So this is how you complete the what is called circular items, particularly cylinder, cone, frustum of cone and block. So in coming sessions we will use these as primitives, okay, basic solids, and then go for combination of solids. So suppose that the frustum of cone is centrally placed on the circular block. How to do it? So let us try them only one simple problem, and that, and then work out. Here only let me try. So problem may be the frustum of cone is centrally placed on a circular block. So how to do it? Okay. Okay, sorry. Problem. Fine. Now simplest item is square block with some pyramid, small pyramid. Now since I have both the primitives, let me try. Okay. Now combination of solids, they say the frustum of cone of some dimension is centrally placed on the circular block. Now I have selected this, I have to place this here. The top center of the circular block is coinciding with the base center of the frustum of cone. So move this, we make this light because we don't want to. Now see that this is exactly at the center. Yes. Now this is combination. Now you can just see this portion, the selected this portion from this end to this end. Whatever back side of the frustum of cone is not visible. Right now it is dark. How to make it light? So again go for split. That's what you do in combination of solids. So that's all, nothing else. So very easy job. Here again you select and selected this point. Then you make this entity, this particular segment, light. That's all. So that completes the combination of solids. Okay. So this is very easy, particularly isometric projection. So either manually or the computer, especially the square and circular items are very easy to work both in manual and computer. Okay, see, this is what the answer is, the combination of solids. This type of problems will work in coming sessions.